This is the video introduction to Experiment 1, Drying to Constant Weight for the Spring 2014 Chemistry 300 lab. In this experiment, you're going to do a few things, but the one that you're actually going to have to use hands-on experimental technique for is drying a sample of KHP, potassium hydrogen phthalate, to constant mass. The KHP that you get will be relatively dry, but it will have some amount of water in it. And we don't want that. When we weigh out a sample of KHP, we want to know that what we're weighing is all KHP and not water, so that we know exactly the number of moles we add to our titration flasks in later experiments. So what you're going to do today is you're going to weigh out some KHP into your weigh bottle. You're going to weigh it and dry it in the oven, then weigh it again and see how much the mass changes. If it changes by a lot, that means you're driving off water, and so you need to keep putting it in the oven. If it changes by a small amount, less than a milligram or so, you can assume that all the water's gone. The KHP molecule is shown there. Structure is not really important for our purposes. For this experiment, you're going to need to use an analytical balance, which you have probably not used before. The analytical balances are in the balance room, which is the room next to the lab, and you'll be shown this when you come into lab for the first day. You're going to be assigned a balance numbered 1 through 15, and that's the one you should use for the whole semester. There's a bunch of other stuff in the balance room, as you can see here. There's desiccators on the shelves, there's volumetric glassware on the shelves. Anything that's up on a shelf is off limits to you. Don't take anything off the shelves. The analytical balance looks like this, and it looks a lot like the balances you've probably already used, except for all of those digits after the decimal place. These give an accuracy of down to 1/10 of a milligram, and we pay an awful lot for the privilege of getting that. So these things are not cheap, and they should be treated with care. When you come up to the balance, it may say something on the display. When you want to zero it, you can press the button all the way on the right side there, labeled tare, and that will zero the display. It will ignore whatever's on the balance pan, and it will just say, okay, we're starting at 0, whatever we add from now on is going to be measured. So in this case, you're going to weigh 10 grams of KHP, and so that's about what it will look like in your weigh bottle. So what I did for this was I put the weigh bottle on the balance, I pressed tare to have it ignore the mass of the bottle, and then I weighed in 10 grams of KHP. There are 3 weighing methods that are discussed in your lab manual. We're going to use the second one, weighing in, for this step. The first of those is direct weighing, and it's just what it sounds like. You take your balance, you want to weigh an object, and so you put that object on the balance and read the number that it says. That's just direct weighing. Weighing in and weighing out, in both cases you want to ignore the mass of something. For weighing in, you want to ignore the mass of the container you're weighing into. And so in this case, you put your weigh bottle, which doesn't weigh very much, on the balance. You press tare so that the balance says 0. And then you add your sample to the weigh bottle. The mass that's displayed on the screen of the balance is going to be just the mass of your sample. Weighing out is sort of the opposite. You start with what's shown here, the weigh bottle full of sample, and you press tare, starting at 0, so that the weigh bottle and the sample, the mass of both is ignored. Then you take some of your sample out of the weigh bottle and put it into some other container, whatever you want. And so in this case, the mass that you're looking for is going to be displayed on the screen as a negative number. These balances will display 250 grams in the positive and negative direction. Weighing out is a good technique when you want to put your sample into something that has a mass of greater than 250 grams. So you would overload the balance if you weighed in or used direct weighing. So in that case, you weigh out. You start with your sample in a light container, take out a little bit, and the balance will be able to display the number that you want. But again, we're going to use weighing in this case, because you're going to be starting with an empty weigh bottle and you want to add to it 10 grams of KHP, approximately. When you are doing this, you notice that there was the 0.1 milligram accuracy on these balances, and so anything that you introduce to your sample that is not just sample, or remove that's not just water, is going to show up, and it's going to give you false positive or false negative results. And that's true for a few of the experiments we're going to do throughout the semester. So, whenever you're drying a piece of glassware, in this case a weigh bottle, to constant weight, You never want to touch it with your hands because your hands have oil on them, and that oil will be transferred to the weigh bottle and will affect the mass that you're reading on the balance. There's a pretty easy way to get around this, which is to fold up a Chem wipe, as shown in the picture there, and use it like a little handle so that you're not actually touching the bottle. You don't have to do this for glassware that you're not weighing to constant mass or that you don't care if the mass changes. You only have to do this when you need the mass to stay constant between weighings. When you go to dry your weigh bottle, you're obviously not going to touch it with your hands, but you also don't want to be taking a hot weigh bottle directly out of the oven. And so we're going to use the diagram on the left there, which is shown in your lab manual, to dry the weigh bottle. This is what it's going to look like when it goes into the oven and when it has sample in it. So you're going to take a small beaker, you're going to put your weigh bottle in there with your lid off. It can be either on its side or it can be left out entirely. You're going to cover the whole thing with a watch glass. And you're gonna, you should label the beaker, not the weigh bottle, with a piece of tape with your name so that you know whose is whose. It's going to put in the oven like this, it's going to come out of the oven like this, and when you take it out of the oven, it's going to dry in your desiccator. So an important thing when you choose the beaker you're going to use for this, make sure it fits in your desiccator. Don't use a 1 liter beaker for this. The procedure you're going to follow is shown here, and it's also in your lab manual. When you come into lab, you're going to get a desiccator and you're going to label it with your name and your lab day, and there will be some weigh bottles in it. Those can be assumed to be clean, but should not necessarily be assumed to be dry. So your first step is going to be drying them to constant weight. So you're going to weigh the bottle first, put it in the oven for an hour in the beaker setup shown previously, cool it in your desiccator until it's totally room temperature, and then weigh it again to confirm that it's completely dry, that it lost less than 1 milligram of water. It should be the case for everybody, but if it's not completely dry, you put it back in the oven for 15 more minutes, weigh it again, and make sure that it didn't lose any more water. It's really important to weigh these bottles when they're cool, because weighing hot glassware will give you very inaccurate results with these balances. Definitely more than 1 milligram of error, and so your results won't tell you anything about whether the bottle is completely dry or not. Once your bottle is at constant mass, handling it with Chem wipes, you'll take it back to the balance room and get KHP out of a desiccator that'll be back there, and you'll weigh in about 10 grams. You'll record the weight of the bottle plus the KHB in your lab notebook, dry it for an hour, and weigh it again. And you want the bottle plus KHP system to lose less than 1 milligram of water in order to be considered constant weight. This might not be the case for everybody, so again, do another 15 minutes in the oven, let it cool to room temperature, weigh it again. You have plenty of time to do several cycles of this. It involves a lot of waiting around, but you have time to do it. Your data analysis is going to be pretty straightforward for this. You're going to do two things. First of all, determine whether your weigh bottle and KHP reached constant mass. Did it lose less than 1 milligram of water at a time? The second thing you're going to do is determine percent water that was in the original KHP sample that you received. So you figure out the total amount of water that your sample lost from the time you put the KHP in the weigh bottle until the time you determined that it was at constant mass. Figure out what the wet mass of your KHP was, the mass that you initially weighed into the bottle, and then divide to figure out the fraction of water in the original sample. Now, I should note, to do this, you need to not tear the weigh bottle before you weigh into it. This is a slightly different procedure than what I talked about earlier. But since you already know the mass of the bottle, you need to know the whole number, the mass of KHP plus the bottle, in order to get an accurate reading of how much water it lost. Okay, but then when you figure out the percent water, you want to use the mass of just the KHP, not the KHP plus the bottle.